Hello dear students, this is lecture 12 continued for your second unit. In yesterday's lecture we discussed about unit vectors, how to calculate unit vector, magnitude of a vector, and we also verified that magnitude of unit vector is 1. Now there are some more definitions, small definitions related to vectors. We'll continue forward. Equal vectors. So vectors will be equal vectors if they are same in magnitude and they are same in direction. Then we can say these are equal vectors. Like here, A vector is equal to B vector because they are same in magnitude, their length is same and their direction is also same. Negative vector. Consider a vector A and then consider a vector which is same in magnitude but opposite in direction. Let us say B. So if magnitude of A is equal to magnitude of B and direction of A is opposite to direction of B, then we can say that B vector is equal to minus A, or we can say negative of A, negative vector. Next is co-initial vectors. If the vectors are having their same initial point as it is mentioned by the name itself, co-initial. For example, look at vector A, vector B. They are having same initial point, let us say O, then they are co-initial vectors. The most common example of co-initial vectors is component of a vector and vector itself. For example, consider this A vector, then it is going to be its x component ax, and this is ay, its y component. Then we can say that ax, ay and a, they are co-initial vectors because they have same starting point. Next is collinear vectors. Collinear vectors are those vectors which may or may not be equal in length, but they are parallel to each other. So here you can see A and B are collinear vectors. Direction in collinear vector can be opposite also. For example, if this is vector C and this is vector D, they are still collinear vectors. Coplanar vectors. As the name is suggesting, coplanar vectors are those vectors which lies in same plane. For example, these vectors which I am drawing, A vector, B vector and C vector, all these vectors, they are coplanar vector as they lie in same plane. For example, they are lying in the plane of screen of your mobile. The vectors whose initial point is fixed, for example, consider this vector A, which is free to move or rotate, but it cannot change its initial point, then it is known as localized vector. So a localized vector is a vector which can rotate about its initial point, but its initial point is fixed or localized. So such type of vector is known as localized vector. Non-localized vectors. So comparing to localized vectors, if the initial point is not fixed and you can move the vector freely for doing your calculations, and their initial point is not fixed or localized, then they are known as non-localized vectors. They are also known as free vectors. Next is very important, position vector and displacement vector. Please pay close attention and as I'll teach you position vector and displacement vectors. Consider this coordinate system, and in this coordinate system consider 2 points, point 1 and point 2. Okay, this is our origin. Now consider a vector which is being drawn from origin to point 1. This vector is known as position vector of point 1. Let us represent it by r1. So r1 is going to be position vector of point 1. जो r1 वेक्टर है वो आपका जो ओरिजिन से स्टार्ट हुआ है और उस पॉइंट तक जा रहा है, ये पॉइंट को हमने 1 पॉइंट बोला है, तो इस वेक्टर को हम पॉइंट 1 का पोजीशन वेक्टर बोलेंगे. In the same manner, when you extend a vector which is starting from origin and extended up to the point 2, it is known as position vector of point 2. Let us represent it by R2 vectors. So it is very simple. If you are having any point in space and you draw a vector which is starting from origin and terminating at that point, is known as position vector of that point. As you can see here, R1 is the position vector for point 1 and R2 is the position vector for point 2. Okay, now let us consider the coordinates of one point are x1 and y1. Let us say coordinates of point 1 are x1 and y1, and similarly coordinates of point 2 are x2 and y2. So you must know this, that we can write these vectors in component form. So in component form it is very easy to write your r1 vector as the coordinates of point 1 are x1 and y1. You can write x1i plus y1j. Similarly, you can write r2 position vector as x2i plus y2j. So it is very easy to write position vectors. जो भी हमारा गिवन पॉइंट है उसके जो कोऑर्डिनेट है उसके x कोऑर्डिनेट के साथ i और y कोऑर्डिनेट के साथ j लगा दो आप, तो वो आपका कंपोनेंट फॉर्म हो गया. अगर हमारे पास यहाँ पे 3 डायमेंशनल कोऑर्डिनेट सिस्टम होता और हमारे पास z कोऑर्डिनेट भी होता तो हम प्लस में z1 k और सिमिलरली हम यहाँ पे r2 के अंदर हम z2 k लिख सकते थे. ठीक है. Now let us talk about displacement vector. So as now you know what are position vector and displacement vectors. Now let us consider this displacement between point 1 and 2. Obviously this distance is fixed, but we can assign two directions to it. One can be 1 to 2 or it can be 2 to 1. Let us first discuss about direction from 1 to 2. This vector is known as displacement vector, and this displacement vector can be written as r1 2. So this is your displacement vector from point 1 to 2. In the same manner, if I will write negative of this vector whose magnitude is same but direction is reversed, that is r21, which is my displacement vector from point 2 to 1. So they are both having same magnitude. As you can see, r12 has same magnitude as r21, but as their directions are opposite, their magnitudes are same, they are also negative vectors of each other. So r12 is equal to minus r21. Now what about the component form of these vectors? It is very easy to write. If you will apply triangles law, we are going to discuss it later, but first you can remember it. It is very simple, like r1 vector plus r12 vector is equal to r2 vector. So if you want to write vector r12, you can always write it like r2 vector minus r1 vector, and similarly you can write for r21 vector as r1 vector minus r2 vector. And you already know about r1 and r2 vectors. So if you will subtract, you will subtract corresponding component only, like we will subtract x1 from x2 and y1 from y2. We will subtract only the corresponding components. So if I will write r12 vector, it is r2 minus r1. Subtracting the corresponding components, I can write x2 minus x1 I plus y2 minus y1 j. So this is your displacement vector r12. You can see this vector here. This is your r12 vector, this is your r12 vector, and you just wrote it in component form x2 minus x1i y2 minus y1j. आप इसको ऐसे भी याद रख सकते हैं, बहुत आसान है कि जो डिस्प्लेसमेंट वेक्टर है इसके टर्मिनेटिंग पॉइंट पे जहाँ इसकी टिप है वहाँ के कोऑर्डिनेट में से अगर आप इसके इनिशियल पॉइंट का कोऑर्डिनेट सब्ट्रैक्ट करेंगे तो आपको इस वेक्टर का x कंपोनेंट मिल जाएगा, जो कि इसका x कंपोनेंट है x2 माइनस x1 y2 माइनस y1, इसका आपको y कंपोनेंट वेक्टर का मिल जाएगा। और मैग्नीट्यूड के बारे में हम कल पढ़ चुके हैं। अगर हमारे को पोजीशन वेक्टर का मैग्नीट्यूड चाहिए वो निकालना बहुत आसान है, हमने कल पढ़ा। तो हम r1 का मैग्नीट्यूड लिख सकते हैं कैसे, x1 का स्क्वायर प्लस y1 का स्क्वायर और फिर इसका स्क्वायर रूट। सिमिलरली वी कैन राइट मैग्नीट्यूड ऑफ r2 वेक्टर x2 का स्क्वायर प्लस y2 स्क्वायर and then whole square root. Similarly, in the same manner, we can write the magnitude of r12 vector. The magnitude of r12 vector is x2 minus x1 square plus y2 minus y1 square and then square root of entire term. In the same manner, we can write r21 vector as r1 vector minus r2 vector, subtracting the corresponding terms x1 minus x2i plus y1 minus y2 j. So that is your r21 vector in component form, and we can write the magnitude of r21 vector x1 minus x2 square plus y1 minus y2 square and then square root. So I think you understand how to write the position vectors of given points and how to write the displacement vectors corresponding to point 1 to 2 or point 2 to 1. So next is multiplication of vector by a scalar and a number. So first we will start with a number. So you consider a vector, suppose this a is a vector which is having two magnitude. Let us say it's a force vector, it is 2 Newton. If you will multiply this a vector by a number, say 3, then it will become 3a vector. So a vector whose magnitude is 3 times the magnitude of a. So the direction will remain same, the multiplication by a scalar number will not change the direction. So this is your vector 3a, and its magnitude is obviously 6 units comparing to 2 units magnitude, because as I already told you, in geographic representation length of vector represents its magnitude. So what you can say at this point, multiplying a vector by a number doesn't change its direction but increases its magnitude by the number itself. And let us have an example what will happen if we will multiply a vector by a scalar. Again, let us consider this is a vector a whose magnitude is 2 Newton, and let us say I multiply it with some scalar quantity, say time. So if I will multiply it with a time, say t is equal to 10 seconds, and I multiply my vector a with time, then it will become a quantity, let us say this time is a scalar, so it will become t a vector, t a scalar multiplied by a vector, so it will become t a vector. The multiplication is still a vector quantity, but its magnitude is increased by the value of the scalar, and also the unit of this product has been changed now. So after multiplying it with t is equal to 10 seconds, it will become 20 Newton second. That is your ta vector after multiplication It's a new vector whose magnitude is 10 times the previous vector, and unit is also changed. It was 2 Newton force only multiplied by 10 seconds, so it's now Newton second. And the direction is maintained in the same manner in which the direction of A was there. So you can draw it like this, whose magnitude is 10 times more than magnitude of A vector, which was 2 Newton, so its length is 20 units. So this is your TA vector. So that is the effect of multiplying a vector by a scalar. So that is enough for today's lecture, and tomorrow we will study about resultant vectors and vector addition. We'll do vector addition by both ways, that is by geometrical method as well as by analytical method. This is very important section going on. Do not take it lightly. Put your 100%, try solve examples, study the definitions, understand the textual representation, notation and graphical representation. And if you are having any doubt, we are going to have a Zoom session on Thursday and I'll take your doubts there. Thank you. Take care.